Hello everyone, welcome to today's lecture. In this lecture, we are going to discuss about direct memory access. In our previous lecture, we have seen two different types of data transfer mode, which is a programmed I/O and the interrupt initiated I/O. So in the programmed I/O, the processor keeps on scanning whether the device is ready for data transfer, and if an I/O device is ready, the processor fully dedicates itself in transferring the data between I/O and memory. So it transfers the data at a high rate, but it can't get involved in any other activity during the data transfer. So this is the major drawback of the programmed I/O approach. The second approach is the interrupt initiated I/O. So in that method, whenever the device is ready for data transfer, then it writes an interrupt to the processor. So the processor completes executing its ongoing instructions and save its current states, then switch to data transfer, which causes a delay. Here the processor doesn't keep scanning for peripheral ready for a data transfer, but it is fully involved in the data transfer process. So it is also not an efficient way of data transfer. So both of these methods of data transfer are not useful for transferring a large block of data, but the direct memory access method completes this task at a faster rate and is also effective for transfer of large data block. So this is the main advantage for the direct memory access. Now let's understand what is actually the DMA. So the direct memory access transfers the block of data between the memory and peripheral device of the system without the participation of the processor. The unit that controls the activity of accessing memory directly is called the Dma controller. In previous both the approach, we are transferring the data between I/O device and the memory with the help of CPU. But here in the DMA, we are transferring the data between I/O and memory without the help of CPU. Here we are not using CPU to transfer the data, but here we are using one controller, which is a DMA. Yes, it is same like a CPU, but the CPU has so many tasks to done. But in the DMA, the most important work to do is to transfer the data between I/O device to the memory. So this is with this way we can improve the data transfer methods. So in the direct memory access, the interface transfers the data in and out of the memory unit through the memory bus. Okay, so here we are using one memory bus. The transfer of data between a fast storage device such as magnetic disk and memory is often limited by the speed of CPU. Removing the CPU from the path and allowing the peripheral device manage the memory bus directly would improve the speed of the transfer. So this transfer technique is called the direct memory access. During the DMA transfer, the CPU is idle and has no control of the memory bus. So here CPU will not involve in this data transfer. So the CPU has no control on the memory bus. A Dma controller takes over the buses to manage the transfer directly between the I/O device and memory. So now let's understand it with the diagram. So this is the diagram for the direct memory access. So here is the peripheral device. Now suppose the peripheral device are ready to accept data or ready to send the data. At that time, peripheral device sends the DMA request to the DMA controller. So this is the DMA controller, this is the peripheral I/O devices, this is the RAM, and this is the CPU or the processor. So if I/O device wants some output or wants to send some input, at that time peripheral device sends the DMA request to the DMA controller. Okay, now DMA controller receives the request. Now here after that, here BR means bus request, RS means register select, DS means DMA select, BG means bus grant. Okay, and here are the interrupts. So these are the signals that DMA signal can send. After getting the DMA request from the peripheral device, DMA control sends the BR request, means bus request, to the CPU. So here we are requesting for the bus. Okay, so after getting this request, the CPU sends the bus grant request, here BG, bus grant request, to the DMA controller. So when CPU sends bus grant, means we all know that there are three types of buses: the data bus, address bus, and the control bus. So here read and write are the control bus, address bus, and the data bus. So when processor sends the BG signal to the DMA controller, it means this read and write address and the data bus is accessed now accessed by the DMA controller, and at that time CPU does not use that buses. Okay, so these buses are ideal in the CPU when DMA controller use that buses. So now the DMA controller has the access on data, address, and the control bus. Okay, and this all the bus are connected with the RAM also. So in the RAM there is read, write, address, and data buses are also there. So this is directly connected with RAM. So now you can see that all the access is given to the DMA controller. So now DMA control is directly connected with the RAM, so no need to use CPU here. Okay, here address select line is the address bus of the RAM, so this is directly connected, and this address select is connected with DMA select and the register select. Now here one thing needs to be noticed, that when the DMA controller receives the bus grant request from CPU, at that time DMA controller sends the DMA acknowledgement to the peripheral devices. It means that I am ready to accept the data. Yes, so after getting the acknowledgement, peripheral device sends the data to the DMA controller. Now DMA control can transfer the data directly with the memory. Okay, so after transferring the data, now DMA controller sends the interrupt signal to the CPU. So after that, the access of this data, control, and address bus will be taken by the CPU, and the process will stop here. So this is the process of transferring the data. So here the main component who is responsible for transferring data is the DMA controller. So the DMA controller needs the usual circuit of an interface to communicate with the CPU and IO devices. The DMA controller has three registers: address register, so word count register, and the control register. So here let's understand each one in detail. So the first is the address register. So the address register contains an address to specify the desired location in memory. Okay, so address register stores the starting address of the memory. Suppose the RAM, here in the RAM the first address is start with the 10. So the first address is 10, so that is stored onto the address register. The second is the word register. So suppose in the RAM a bunch of word is stored, so from that 0th location to the suppose 50, so this is the whole the word of bunch of words. So in that there are 50 words stored, so total count is 50. So that is why this 50 count is stored onto the word register. And the last one is the control register. So the control register specifies the modes of transfer. So mode of transfer means there are mainly two control, which is read and write. So control register has a two value, either read or write. Okay, so the CPU communicates with DMA through the address and the data bus and with any interface unit. DMA has its own address which activates the DS and RS line. The CPU initializes the DMA through the data bus, as I said. Once the DMA receives the start control receives the start control command, it transfers the data between the peripheral and memory. When BG is equals to 0 and RD and WR are the input lines allowing the CPU to communicate with the internal DMA registers. So here, when the value of BG is equals to 1, at that time we can say that CPU grants the bus request to the DMA controller. So all this bus access is given to this DMA controller. Yes. So at that time the CPU does not use this buses. If the value of BG signal is equals to 0, it means the bus grant request is not provided to the DMA controller, and all the buses are with the CPU. So at that time DMA does not use any of the bus. So that is all about the direct memory access. So thank you so much.